Hi everyone, so we're just going to go over that little bit in lab that we didn't get to that I said I was going to cover. So this is just the document on your Canvas. It's a PDF on lab safety and micropipetting. We pretty much went over all of this. The only thing I would have you guys take a look at is going to be this one right here, right? That leads into the metric conversions that you are going to need to do for homework. And again, if you guys need extra help or further questions on that after you have done and use the resources that are already in the module, let me know and I'm happy to demonstrate and record a video. But anyway, we're going to move on to the next spot. So what you really need for the homework is going to be this one right here, right? So because it's going to ask you to be able to convert from microliters to milliliters. So you are using this particular conversion here. So pretty much what you're going to do is that you're going to divide everything by 1,000 and then that will get you to the milliliter. So keep that in mind as I scroll to the actual page here. So here's the data table that you guys wrote down, and if you didn't write it down, here it is again. I don't quite remember the numbers that we picked, so I'm just gonna pick other numbers and then just model your calculation based on that. So let's just pretend these were the numbers here. I think these are pretty close. I don't know, they might even be the same thing. Anyway, I digress. So pipette type, you should be able to do that on your own, so I'm not going to answer that for you. What we're going to focus on is column 3, 4, and 5, right? So for column 3, it says expected weight. So if you notice, the units that they want you to use is 1 ml in order to be able to convert it to grams, right? But if you notice over here, we are using microliters. So this is where that other chart that I showed you comes in handy, because you have to convert your microliters. I'm going to write it down here. Your microliters, you got to convert it to ml. And again, all you have to do is divide by 1,000. So you're going to take your number. So look, for example, 15, right? Divide that by 1,000, or you can just move the decimal 3 times over. So that's going to be 0.015. Right, so all those numbers you're going to divide by 1,000, it'll give you the ml. Now you are able to use this conversions, and it's just a 1-to-1 conversion. So 1 ml equals 1 gram. So this number right here, it's going to be 0.015 ml, and since it's a 1-to-1 ratio, then you would get 0.15 grams, which is what you're going to write over here. Oh, too many zeros. Grams, right? Because weight is measured in grams, right? And then just be mindful, I'm going to erase the next parts here so I can do number 4. So if you need to pause. And then for column number 4, so I'm going to erase this. For column number 4, it wants you to do filled minus empty tube. Now again, I'm just going to make up some numbers because I don't know what your weights are. So let's say, for example, your empty tube, right? Your empty tube was, I don't know, 5 grams, which is totally too much. That is way too much for a microcentrifuge tube. So let's say your empty tube was 5 grams, right? Let's say your filled tubes with the water was 6 grams. So again, this is empty. And then this is full, we're just subtracting. So you would get, in this weird instance, 1 gram, right? Which would then be, hopefully you'll tell me, is the water, right? Because we're subtracting the empty weight, which will give us the water. So whatever that number is, you're going to put it here. And then the unit is going to be grams, right? And then percent error. Percent error tests how accurate the micropipette is technically, right? It's gonna tell you if, let's say, it's 100% accurate, that means that your expected and your observed are like 100% exact or accurate. If it's lower than that, then there's some kind of calibration that you need to do. So in order, I'm gonna erase this bottom part to do this. So in order for us to do that calculation, we actually need to take a look at this equation up here, right? So this is the one you're looking at to fill in that box. So expected weight, right? Expected weight will be this one right here. So whatever number you have for that column minus actual weight, which is this one, right? Divided by expected weight, which is this one again, right? So if I were to set this up, it would be 0.015 grams minus 1 gram over 1 gram. Now this setup, because it is so weird and so inaccurate, is going to give me a negative number, but it should not give you a negative number, right? So it should give you some sort of decimal and it should be positive, but I'm not going to calculate this out because I already know this is going to be negative and that's not what we need. So let's pretend that I got 0.45. Right? Let's just pretend. I know that's not mathematically sound, but let's just pretend. And so what you're going to do is you're going to multiply it by 100 and it'll make that a percentage, or move the decimal 2 over, right? That'll give you the percentage. So then that percent, whatever it is that you get, you put it over here and there you go. Right? So hopefully if these pipettes were calibrated properly, you should be as close to 100 as possible. Right? If you have any questions about how to fill in the rest of the table, let me know. But hopefully that makes sense. If not, email me and I would be happy to do that for you guys again. And I'll see you guys next lab class.